Not bad, not bad. What is going on, guys? My name is Amos, and welcome to part, I think, is it 6 or 7 of us building AutoLib, the most awesome automata theory library, right? So in this video, we want to see how we can generate dot files. We want to see how we can generate dot files, yeah. And we'll probably get rid of the print automaton function because it won't be saving us, you know, it won't be of any use to us because we'll now be trying to we write everything to a dot file, and from that dot file we try to see whether what we've written is correct, or something like that. So we'll get rid of this textual prints and all that, so we'll be able to like follow everything from the dot files. Probably in the next video we'll see how we can maybe also write the information to in a JSON format that we can like provide to some web tool to like generate the graph of whatever it is that we want to write or represent. So if you don't know what the format of like a dot file, uh, this is we basically define a graph. Let me see if I have something to show you here. Right, so if you look at this here, if you look at what we have here, this is an example of a graph that we've defined. So the name of the graph here is G. So it's a digraph for directed graph. So you see these arrows here. So where you have like, for example, here A is the source, and then it goes to B. So you have like a directed graph, a directed transition from A to B. But what we want to do here is to also write the name of the file. I mean the name of the symbol that we consume as we move from one state to the other, or as we transition from some state A, for example, to another state which is B. So this is how we define the transitions, and then we'll use label to like add the symbols that we are reading here. So we won't have any subgraphs here. We just like have one graph and write everything that we need to write. But we're going to do it a little bit different here. We'll also print information about the number of transitions that the automaton has, the number of symbols it has, as well as the symbols in the alphabet. So we'll print all that useful information to a dot file. Okay, but then we don't want, if we like feed the dot file that I'm describing now to something like Graphies, for example, we're going to have problems. We need after googling, researching, and trying to look for information online, I realized that if you wrap something in like what do we call this, inverted commas, or inverted commas or quotation marks. Yeah, they're known as, they're called quotation marks. If you wrap something in quotation marks, then it is going to be ignored by Graphies. So though it's not like official or it's not standard, I will try to use that approach. And as we like progress, we'll sort of like develop better ways. We'll find better ways of like doing that. So this is what we want to achieve in this particular video. We write a dot file and then provide the dot file to a tool like Graphies. Then Graphies is going to generate the graph of the automaton. So we'll probably get rid of the print automaton function because it's not going to do anything, right? So let's see how that is going to be done. So the very first thing that I want to do here is define the method signature, the function. Okay, so remember, it's going to be a public function. Do we need to return anything when we generate this dot file? Well, it depends, if we probably need to maybe process it a little bit further, we might return a pointer to auth, but it doesn't make any sense, right? So we just return void for now, and these things might change. And we in the future we might like do something different. For now, we'll just say void, and then we'll print whatever I want to print to some file. So what do we expect as arguments? So we expect a pointer to the automaton that we want to write to a dot file, and then we also expect them to provide the name of the file, right? And then from that name, maybe we can sort of like configure paths so that to allow them to print to print or to generate the file in a folder of their choice or something like that. So remember that all public functions are going to be prefixed with auton. Now I keep repeating this in every single video, so it sort of like helps us remember what we are doing and like where we're coming from. So void auton, then we're going to say generate. I'm just going to say generate dot file, because we'll also like generate JSON files and pass that to some web tool that can like generate a graph and things like that. So great stuff. So we need a pointer to the automaton. So I'll say this, and then I'm just going to like write the full thing. If you've noticed, I just like to, even if the names are long and all that, I just like to respect, to give my variables meaningful names. Because if I say auth, for example, auth can mean anything, and I really don't want to introduce, you know, any form of ambiguity to the code that we're writing here. I want it to be as simple. I want it to be very simple and straightforward. So automaton. Then we'll also, and since we're not changing this, we can just say const. We can just say, okay, this is going to be const. And in a separate video, I think I'm going to like define some library related variables, because we don't want to write something as long as, you know, const automaton t. We want to shorten this name. So we might like define some library type definitions, and that would like help us shorten these long types that we have here. That might be helpful. Okay, so now that we have this, the next thing that I want to do here is to pass in the name of the file. So I'll just say const char, then I'll just say file name. Okay, file name makes sense, yeah, because it's the name of the file we're actually giving as a parameter. So I'm just going to grab this function, prototype it in the header file, so that when we want to test, when we want to like perform some tests in the main.c file, we'll be able to call that function by including the header file where this function is going to be prototyped. So it doesn't matter where you put it in the auton.h file, as long as you throw it, just put it in the file, right? So I'm just going to put it after add transition and generate dot file. Okay, everything is good. So I'll go back to my auton.c file. Now the very first thing that we want to do is to asset the arguments that we receive here. We need to check if the arguments are no. Well, we don't want to do anything. We want to exit from this particular function. So we're going to call our macro. Remember that in the previous video we defined a macro for that. So we say asset not no. Then we're just going to pass in the automaton. If it's no, we'll go ahead and exit this function. Do not proceed to the next step. Now this is going to be very, very helpful. Because if we don't do this, we are basically assuming that what we are receiving is correct, but we might not always receive the correct information. So we need to protect ourselves from all sorts of problems that we can have if we leave out this this part that we have here. So if we assert that if everything we do the assertions, everything is okay, and for now I'll just leave it as a to-do. But I'll just leave it as a to-do. Maybe we would want to configure paths. Like I said, we want to like and of course I'm using an extension here, some extension to make the to-dos appear the way they are appearing now. And if you're interested in the extension, I'll show you at the end of the video what extensions I'm using to make the to-dos stand out the way they are appearing now. So this is just to remind us that, okay, we have something that we've not done here, and we need to probably come back and change a few things and add what we're supposed to add here. Okay, so what we need, I'll just say configure paths for now. Configure paths, and we're actually using C17. If you've looked at the cmakelist, the text file that we have here, we're using C17. Okay, in case you're wondering what version of C we are using, we're using C17, the C17 standard. Okay, that's what we are using. I believe the latest version should be 21, but I think 21 is too new, because initially I wanted to like do everything in C89 or maybe C99, something C89, C99, because if the older the version, it means it can be, if we use an older version of C, it means it can run on any particular device, anywhere. It can run anywhere. Okay, yeah, that's the benefit. But then, okay, we want to like benefit from the new features and all that, so that's why I decided to use C17, in case you're wondering. Great stuff. So we configure the paths. For now, we're just like, okay, now we need to save file. hopefully we've included the standard library or wherever this file is defined. Now this gives us a pointer, so I'm just going to say dot file. Okay, dot file like so, and then we want to like open the file in write mode. We want to open the file in write mode because we are writing to the file. Okay, I want to write to file name. What do I want to write to file name? Oh, I want to open it in write mode. Okay, so we'll say W. We want to store it as a text file. We want it to be a text file, so that's why I'm saying W here. Okay, we want it to be a text file because we need to be able to modify, to make changes to the file if we want, and later on we implement a method to read the these are dot files. Yeah, so we'll probably do a naive implementation of the function that is going to read that is going to read these dot files. Maybe later on we can use parsers to like read the information in a more robust way. Okay, so we have a dot file. Now the next thing that we have to do here is to do another asset no, right? Because this is a pointer. If it fails, I think this returns no, right? Yeah, it returns no. If this fails, it returns no. So we need to do another assertion here. So we need to do another asset not no, and then we throw in our dot file here. So this, if it's no, please go ahead and exit this function, because if we cannot create a file, then we cannot write to the file, and so it makes no sense to like continue or to go to the next level, or maybe look at the next do some other things. So we want to exit the function, so we'll call our macro asset not no. We pass in the dot file. If everything is good, well, we'll go to the next step. So remember, if you look at we need to define a directed graph. What we need is a directed graph, because we need transitions where we can see the origin and the destination, and also read some sort of symbol, some symbol, right? That's what we want to do. So we need a diagraph for that. Okay, so the first thing that we have to do is, so fprintf, fprintf. Now with fprintf, you have to pass in like a format. First, it says you have to pass in a file stream. So for the file stream, we're going to pass in the pointer that we get from fopen, right? So that is going to be dot file, and then we pass in a format. What I just want to say here is, what I want to do here is digraph. Di means directed, and then graph, we need a directed graph where we'll be able to see like the arrowheads with the arrows that we're going to draw. So we have digraph. Then I'm just going to call it automaton like so. If they want to, like, they'll be able to edit the text file, so they can change the name if they really want to change the name. So yeah, and for now, open Calibres, okay, and then we throw in that new line so that we write the next thing on a new line, on a separate line. Okay, that's what we want to do. So this prints this gives us the first part here, digraph, and the very end we want to print we want to say fprintf, I think, yeah, fprintf. Then to the same dot file that we have here, we want to we want to like write the closing curly brace like so, and maybe just like this is not necessary, but we also want to like insert a new line after writing this, right? Because we won't write anything after this, but just to like keep things consistent and organized, so we like throw in that new line again after writing. And then in between we need to write the number of like states, the symbols of the alphabet we are using, and then we also like need to write maybe the number of transitions. No, it's not important. The number of transitions is not important, because we'll infer the number of transitions from, I think, the transitions would define. Okay, so it doesn't make sense. Okay, so let's now write the number of states. So remember, like I said, though it's not standard, if you like write something in like in quotation marks, it's going to be ignored if you like give it to graphies. Okay, so that's the approach we're going to follow, because what we want to do with these dot files is to generate graphs of of automata, graphs of automata. That's what we want to do. So for graphs, what we need is what we need is, you know, just the nodes, define the nodes and define the transitions and the labels. That's all. That's what we need to print a graph. But later on, we want to read from these files. We want to create an automaton from these files, and so we have to have, you know, this, you know, other, we have to know the number of states, for example, the symbols of the alphabet, and though we're not going to use it for like visualizing the graph, we need to store it for now. Okay, so I'll have to put, I'm going to put it in quotation marks. So anything that I don't want to show on the graph, I'll put it in quotation marks. Okay, so fingers crossed everything should work. Okay, so we have fprintf, and then we throw in the file stream, which is our dot file. And just to format things, you know, just to properly format things, I'm just going to say space. And then what do I need? I need the number of states here. Okay, I need to write num states and then also throw in that space here. And I need to put the number of states in Kelly, in quotation marks, sorry. But then we need to escape. We need to like, because we're using the, for strings, to print strings, remember that we use the quotation marks, right? So if I add other quotation marks inside, C is not properly going to like treat it. It's not going to treat it properly. It's not going to understand what we're trying to do. It would think that the new quotation mark that I've added inside is like the ending quotation mark, and so it won't like read whatever is at the end. So it will be a compile time error. Okay, it will be a compile time error. So we need an escape sequence. We escape, so forwards backslash and then semicolon, and then I'll say %d, right? %d to print an integer. So I'm going to say %d, %d like so. And then I also need another, I think, another quotation mark. Again, I need to escape this with the, so that should give us that. This is the format, so num states, and then we should be able to provide the, so automaton and then num states. Great job. So we also need the number of symbols. So I'm just going to like copy this. I'm going to copy this, put it here, and instead of saying num states, I'm just going to say num symbols, and then this is automaton, and then we point to the alphabet. We also point to the number of members, like so. Okay, and new line. Yeah, let's not forget to add the new line, because if we forget to add the new line, everything will be on the same line. And yeah, so this is what we have. So we have the number of states, we have the number of symbols, and everything looks okay. Let's also print the symbols of the symbols, the alphabet symbols, our set sigma. So let's print the symbols here in the file. Here we need the for loop. We need to remember that the symbols are stored in a dynamic array, so we need to like loop through that array, and each time we read a symbol, we need to write it to the file. So we need this. So I'm just going to say fprintf. We need one fprintf, then I'll leave it here. We need another one after the for loop, so fprintf, like so, and then close that, and fprintf, we pass in the file stream, which is, you know, our dot file, like so. Yeah, we pass in our dot file, and then let's just say for the format, again space, and then I'll say alphabet, right? Alphabet, and then space equal to, and then remember I need to put it in whatever I'm going to write here has to be in quotation marks. Okay, remember, so I'll say backslash opening quotation, whatever quotation mark, and then so we have that, and then here we need to close, we need to be able to find a way to like close that. Okay, and then a new line again. So if what I'm doing is not making any sense, I think it's going to make a lot more sense if we like see what the files we're going to generate. I'll like re-explain what we are writing here so as to make things, you know, better for you. For now, you know, just follow what is happening. So we need to close this. So we need I'll say backslash again, and then quotation or quotation mark, and then we'll throw in that new line, so that after we print the symbols of the alphabet, we can now start on a separate we can start on a new line, and we can start on a new line and write you know, something else. So I'm going to yeah, so let's now loop through the symbols that we have. Let's loop through all the symbols. So for now, we can just say size t, because we know that the index is always positive, right? So we'll just say for size t, at least for this particular use case, the index is positive. So instead of saying int, I'll just say size t, and then we'll just say I less than. So we'll just go automaton, and then we'll just go point to the alphabet, and then point to the number of members, and then I want you to increment I. So plus plus I, or I plus plus, whatever, you write it here. So we need to write a symbol. But now these symbols have to be separated by commas. These symbols have to be separated by commas, right? So we have to write something like this. And then let me just write it and then show you, and then maybe explain the problem we're going to run into. Now this is not like a, you know, a compile time error. It's not going to give us a compile time error. It's not a very serious problem, but it's related to how we are formatting things. Like when you print a set, when you print items of a set, you want to separate all the items. When you want to write the next symbol, you separate the two symbols with a comma. But then if it's the last symbol, it makes no sense, you know, printing the comma at the very end, right? So we have to check if we are reading the last symbol, we don't want to put the comma at the end. So that formats things, you know, a little bit better. It gives us a you know, a better view. Okay, right. So let's actually check directly here. So if it's the last symbol, I don't want to add the comma. If it's the last symbol, so if I is equal to, remember we have automaton. Now go ahead and point to the alphabet. Now remember that arrays are zero index based. What that means? It means that the first index is 0 and it's not 1, right? But then num members is the length, is the number of items in the array. So we need to subtract 1 from that from that count. That should give us, you know, all the possible indices we can have, all the possible values I is going to take, and automaton dot alphabet dot num members minus 1 is the last index, right? So if I is the last index, well, since we will only have one thing here, it doesn't make I won't use curly braces here because we only have one line in the if block. So we can not f post t but f print f like so, and then close that for now. And then else, I also want to do something else. Again, it's one line, so just say f print f. Okay, now let's pass in the file stream. The file stream is .file like so, .file. And I think if we execute this, I'll say this at the end. Don't worry. So sometimes I'm like getting ahead of myself. So if it's a last symbol, we want to add a comma at the very end, right? If it's the last symbol, we want to add a comma. Otherwise, we just want to write it. If it's not the last symbol, sorry, we want to add the comma. If it's the last symbol, just write the symbol, don't add the comma. Okay. So we want to go %s. So remember, this is our format, and then we have to like go automaton. This is very, very long. What we are writing is long, so probably have to shorten this. Probably have to shorten this, probably have to shorten this, probably have to shorten this. Num members I, like so. Okay. Okay, we have alphabet and I here. This should give us a string, right? So here we should have the same thing. Here we have percentage s, like so, and then we have automaton, like so, and then this should point to, you know, the alphabet. Go ahead and grab the members and grab the members and then grab I, right? Grab I. Instead of I get the error here. So it's, instead of saying num members, it's I. It's members. It's the dynamic array we are making reference to here. Okay. If it's the last symbol, don't add the comma. If it is not, okay, yeah, that should take care of that. Of that. And maybe just to show you what is happening here, I'm going to we're going to test this function right now. We're going to test this function right now. I want you to see what we're going to print. I want you to see what we're going to print. Okay. We already have some data in the main. Yep. So let's quickly say, okay, let's quickly call generate. I think it's auton generate dot file. Okay, auton generate dot file. Pass in our automaton, and the name of the file is going to be, I'll say example.txt, because it's a text file. We want to be able to edit this file and see the contents of this file. If it's a binary file, we won't be able to see anything. Okay. So fingers crossed this is going to work as expected. So let's clear. So we've not made any changes to our cmakelist.txt file. So there's no need to like regenerate the make file. So all we have to do is to go into our build folder and go mingw32 make. Now let me just increase the height of my terminal window, enter, and it builds. We have no errors, which is good. We have an executable, so we can go autonlib, and that should give us, did it generate the file? It generates the file in the build folder. Now no worries, we'll take care of this a little later. That's why we have a to do there. Let's examine the text file. Check this out. So look, this is what we have. So we've printed the number of states, which is 2, which is correct in this case. We've printed the number of symbols, which is correct again in this case. We're also writing the symbols of the alphabet, which is A and B, but I don't want to have this space here. I don't want to have this space here. So let me just get rid of the space and rerun the program, right? Where am I writing the space? It's here that I'm writing the space. So I don't want the space. I don't want the space. I just want the separation to be a comma. We might write a tokenizer maybe to correctly, handle the spaces and things like that. So we might write a tokenizer for that. For now, that looks good. Let's rerun the program, recompile the program, and see what we get. Well, remember, we are opening the file in write mode, and so we don't even have to delete the existing file. It's going to C is going to automatically take care of that, right? So because it's opened in write mode. So let's recompile our program with mingw32 make, and then let's run the executable. It generates the file. Probably have to install an extension for the dot files. Okay, I like what we have now. So you can see for the last symbol we don't print the comma, and everything is respects the format. Okay, yeah, I'm happy with what I see. So now we can proceed and look at continue with our implementation. So everything looks great at this particular moment. So we have the number of states, we have the number of symbols, we have the alphabet. The very first thing that we want to do is to write the states and the transitions. Write the states and the transitions to our file. Write the states and transitions to our file. Okay, so how do we do that? How do we do that? So it's going to be after, let's loop through all the states first of all. Let's go ahead and loop through all the states. And then from the states, we'll get the transitions and then write those transitions to the file. Remember that there are many ways of representing starting states and ending states. Let me just pull up a quick, maybe a Wikipedia article or something for me to show you what I mean. Let's maybe search for, let's just say automaton. Automata theory. I'm just going to say automata theory. Let's see if we can find some Wikipedia article. Now let's look at the way they are representing starting states and ending states. So here, to represent starting states, they are using this, ingoing arrow here. This ingoing arrow here on S1 means that S1 is a starting state. Now I want to do something different. I don't want to use, this arrow here. I'm just going to use a light color. I'm just going to give the node a light fill color, maybe light yellow or light yellow. I don't want to, go heavy on the fill color. I don't want to use something like red because red is too much. Red, blue, the shade is too much. I just want to go with something as simple as light yellow, maybe light green. I think light yellow will be more visually appealing compared to these, colors like red, maybe like red, crimson, or anything like that. So I'll use light yellow to represent starting states. Now it's also common to shade states like that to say that, okay, they are starting states. And then I'll use a double circle for accepting states. So that's what we're going to do. So the only difference is that for me, for starting states, I'm going to use a light yellow fill color, and then for accepting states, I'm going to use double circles. Okay. Yeah. So let's quickly go back to our Visual Studio and implement this in the most awesome C programming language. Okay, let's loop through all the states. We have the alphabet, we have everything. Let's go ahead and loop through all the states. Okay, again, size T, I, 0, and then I, this time around, it's automaton, and then num states that we're supposed to reference. We are looping through all the states, right? Great job. So size T is equal to I is equal to 0, I less than the number of states. And then we want to go I plus plus, like so. And then do that. Now that we have written this, so if it's a starting state, I just want to set the fill color to be light yellow. So to do that especially with graphies, we will do something like this. I will say fprintf. Okay. We need to pass in the file stream again. Don't forget to pass in the file stream. No, sorry about that. So the file stream is .file, like so. And then what do we need? Format, right? Format. Before we even do that, I need to shorten, first of all, let's have the current state. Let's define the current state. So we'll say a state T, a pointer to state, like so. That would be our current state. And then I'll just say current state. I also have to reference the current transition from this current state. Okay, current state is going to be automaton. It's going to be automaton, and then we go states, I believe, and then I. So this should give us the current state. I think I should also grab the current transition. So at node pointer, like so, and then I should say current transition. Okay, current transition, and then we should say current state, and then we should point it to transitions, which is the head of the linked list that is going to store the transitions or the transition nodes, right? Great job. So this is what we have. So if it's a starting state, so if current state dot is starting, if current state dot is starting is equal to 1, or we can just say if current state is starting, because it's already going to be evaluated as a boolean. So we don't have to say is equal to 1, but just for clarity, I'll leave the is equal to 1 like that, right? We can just like leave it. We can just say current state dot is starting state, and that would evaluate to a boolean, and probably have to, you could get rid of this equal to 1, but I really want to maintain some form of like clarity, and so I'm just going to leave it the way it is. So if it's a starting state, we want to do something. If it's an ending state, if current state and then is ending state, if it's an ending state or accepting state, then we should be able to do something else here. Remember that now we need to print this to the screen. Need to print this to the screen. So we need to say fprintf, and instead of it's current state, right? It's current state, and it's current state. I think it's, yeah, the string represent the representation of the state is that. Let me collapse this to make everything fit on a single line. I don't want the text to wrap. It makes things a little bit hard to see. Right, so if it's a starting state, we want the fill color to be light yellow. Right, we want the fill color to be light yellow. All the nodes are going to be circles, so that this is what the circles mean. This is what the circle part here means. So we do that. Otherwise, go ahead and if it's an ending state, then I want you to draw double circles. So to specify double circles, instead of state, we want to say current state. So to specify that we want double circles for accepting states, we will say shape is circle, and then we'll say peripherals is going to be 2. All right, and then we have that. So this is what we write. Now at this point, I just want us to, now we also have to like close the file at the end, because it's good practice. If you open a file, you must close it, after writing to it or reading from it or performing operations on the file. You have to be able to close the file. Great job. So let's try to compile that. Okay, no errors, cool. Let's try to run the executable. So it should like now generate. So look, but now we do this outside. We do this outside the closing curly brace. So I think we wrote that in the wrong place. So I just have to, we did the for loop outside the closing curly brace. So I just have to like cut this and put it in the correct place. So it has to be after writing the alphabet, right? After writing the alphabet. Let me just introduce another space here. I think that would be more visually appealing if I introduce another space there. Okay, now everything should be okay. Let's compile our program. MING32 make, no errors. Great job. We run the executable. Oh, okay. Let's now see the output. Yeah, this is what we are looking for. Exactly what we are looking for. So you can see that Q0 is, if we go back to our automaton, if we go back to our main.c, you can see that Q0, we've defined Q0 as a starting state as well as an accepting state. So then Q1 is neither a starting nor an accepting state. So that is why we see what we see here. Great job. And instead of saying .text, we need to say example dot, and I'm sure Visual Studio is going to like find some extension that would help us visualize this maybe these dot files. So that's my guess. So let's try that. If we compile the program, okay, no error, great job. And then we run the executable. It gives us a dot file, and I think this is going to be opened by something else. Okay, it doesn't matter. Yeah, but dot is the correct format, not text. Because if I feed this to Graphies, feed this dot file to Graphies, Graphies would generate the graph for the automaton, right? So it has to be has to have this dot extension that we have here. Now let's continue. So we have the alphabet, we have the num states, we have the num symbols, we have the symbols of the alphabet. We are correctly drawing the starting states and the final states. Now the next thing is let's go ahead and write the transitions. Let's write the transitions. Now, as long as we have transitions, while current transition, well, I think it's current transition, yeah. Well, while current transition is not no, as long as we have transitions, go ahead and print those transitions, right? Go ahead and print those transitions. As long as we have transitions, go ahead and print those transitions, okay? That's what we're doing here. This is not transition, it's current transition. It's current transition. It's not previous state, it's from. Okay. It's here, it's current transition. So I'm just like current transition. Okay. It's not destination state, but to. So that's the problem with copy and paste. To and current transition. So let's go current. I believe transition. Input symbol and current transition is going to point to next. Okay. We go to the next transition. Remember that again we have to say current transition. Current transition, yeah. Probably have to like tab this. Okay. Then we go to the next transition, right? So as long as we have transition, remember that current transition is references the current state. If we increment I, then this current state will be updated, so is the current transition. But then within the while loop here, inside the while loop, we're also updating the current transition to point to the next transition. Remember that we have a linked list of transitions, so we need a way to we need to write all the transitions as long as current transition is not known. So this is what this is saying. And then the label part here is go ahead and write the symbol, the input symbol, the symbol that we are reading on the arrow, right? On the arrow that is going to depict, a transition where we'll have like a source and then like a destination, and then on the arrow on the line that is going to depict a transition, we want to write the symbol we are processing as we transition from one state to the other state. So go ahead and write it here. So we need to escape this. We need to. That's why we're saying, because we're putting the symbol in the quotation marks. So we have to use backslash to escape, to make sure that to tell the compiler that what we're doing here is we're not talking about these quotation marks for defining strings. We just want to write it as a string, or we just want to write it as a symbol. Okay, we want to write it as a symbol. That will be it. That will be it. Remember that at the end we have to close the file. Maybe we can print some message. We can print some message to the terminal telling them that okay, everything is okay. Your file has been generated successfully. And if we configure the paths, maybe we have to close the paths here later on. So I'll just leave it as a to-do for now. Let me just save that. And let me just delete this. The dot. Let me go back to my main and just write it as a text file. And let's see if we can find an online tool that is going to read the diagraph, that is going to generate the graph for this for the example that we have here. And I'm going to compare them side by side. If the information that we have is making sense. Let's recompile the program. Okay, no errors. Clear the screen. Now run the executable. Okay, does its thing. And yeah, that is it. That is everything, right? That is all we need to do. So you can see that we have written the information in this format, and I think now we can get rid of the print of the print automaton. Okay, but for now I'll just leave it the way it is. Let's see if we can find an online tool. Let me just copy this that we can that we can use to let's say GraphViz online. GraphViz, do they have an online? Do they have an online version? Okay, great stuff. So they do have an online thing. Let me just, it's still loading. Want to get rid of, maybe we'll wait for it to load. So the engine, yeah, we specify the engine dot, correct. We want to generate, and no, we just want a PNG. Can we say, oh yeah, this is okay. I might download this and put it in the example. So I'll download it as a PNG and not as an as SVG. I'll download it as a PNG. I'm on a slow network, so that's why it's taking very long to load. But then this is where I will be like pasting the thing. This is where I'll be pasting the dot files, and this is where I'll be seeing the graphs. Wow. The engine is correct. PNG. Okay. Yep. Now it's up and running. So let's get rid of this and let's visualize our graph. If I put that, oh, and it works like a charm. So you see that Q0 is a starting state. So you can see this like light yellow fuel color that we have here. Okay, this means that Q0 is a starting state, and then the double circle means that it's an accepting state. Now let's look at the transitions. Let's go back to our main file. Let's go back to our main.c file. Main.c, yeah. So between what transitions do we have? From Q0 to Q1, we read B. Okay, let me go back. From Q0 to Q1, we read B. Okay, and then from Q0 to Q0, we read C. From Q0 to Q0, we read C. Q0 to Q0, we read C. Okay, and then from Q1 to Q0, we read B. Is that correct? Yes, it is. So Q1, Q0, we read B, right? So that is all. In the next video, we want to look at how we can write the same information, but in to a JSON file or in the JSON format, and then we'll probably give it to some other tool and provide the JSON in to some other tool that would sort of like do the same thing. So and then we might also like write a function that is going to convert the dot files to JSON files and do the reverse as well. So that would be nice to have as as a feature in our library. So thank you guys for watching, and I'll see you in the next video.